everyone, welcome to my channel. In this video, I'm going to discuss about reduction in just one single shot. I'm going to discuss shortcuts as well as a brief explanation of the reaction, but I'm not going to discuss about the mechanisms of the reactions. First of all, let us see the reduction of organic functional groups. Here is a general representation of organic functional groups and their reduced products. Let's discuss briefly about each functional group. Aldehyde or ketone? Aldehyde or ketone on reduction produces alcohol. Alpha beta unsaturated carbonyl. These are alpha beta unsaturated carbonyl compounds because it is having a carbonyl compound, and the carbon adjacent to carbonyl is called as alpha carbon and adjacent carbon is called as a beta, and there is an unsaturation between alpha and beta carbon. These products on reduction produces allylic alcohols, or in some cases it can produce saturated alcohols. Acid chlorides, C double bond O Cl. These on reduction produces alcohol. Esters, C double bond O OR. These on reduction also produces alcohols. Lactones. What are lactones? Cyclic esters are called as lactones. Okay. So this is a cyclic ester and it is a lactone. This on reduction produces diol. Here we are having 4 carbons, 1, 2, 3, 4. 1, 2, 3, 4. The first carbon and fourth carbon is having an OH. So this is a diol. Epoxide. What is epoxide? 3-member cycling group which is having an oxygen is called as an epoxide. Epoxide on reduction produces alcohol. In some cases it produces more substituted alcohol, and in some cases it can produce less substituted alcohol. Carboxylic acids. We know that C double bond O OH group is called as carboxylic acid. This on reduction produces alcohol. Imine, amide, nitrile are converted to amines. It is imine. C double bond N is called as imine. Amide, C double bond O NH2 is called as amide, and C triple bond N is called as a nitrile. These on reduction produces amines. Alkyne. What is alkyne? R C triple bond C R dash is called as alkyne. This on reduction can produce either cis alkene or trans alkene. Beta hydroxy ketone. This is a very important application. This is a beta hydroxy ketone. This is having a keto group here, and beta carbon is having a OH group. It's called as beta hydroxy ketone. This on reduction can produce syndiol, or in some cases it can produce antidiol. So this is a general representation of reduction of each functional group. Now we have to see which reagent is used for the reduction of these functional groups. We can reduce these functional groups by using 4 types of reagents: hydride transfer reagents, metal in the presence of solvent, or by using catalyst, or by using some miscellaneous reagents. So by using these 4 types of reagents we can reduce these functional groups. Firstly, let's discuss about hydride transfer reagents. I have summarized hydride transfer reagents in one tabular form. Here I have taken the hydride transfer reagents, and these are the functional groups, and these are the reduced products. Hydride transfer reagents are nothing but it transfers H- to a functional group. Let's discuss about each hydride transfer reagent. Firstly, let's discuss about lithium aluminum hydride. This is the most powerful reducing agent among all hydride transfer reagents. It reduces almost all functional groups. Aldehyde or ketone is reduced to alcohol. Alpha beta unsaturated carbonyl at low temperature is reduced to allylic alcohol, and at high temperature it is reduced to saturated alcohol. Acid chloride is reduced to alcohol, ester is reduced to alcohol, lactone is reduced to diol, epoxide is reduced to alcohol. In this, hydride attacks the less substituted site, producing more substituted alcohol. Carboxylic acid is reduced to alcohol, amide, nitrile or imine is reduced to amine, alkyne is reduced to transalkene. Sodium borohydride is a mild reducing agent. It selectively reduces only some functional groups. Aldehyde or ketone is reduced to alcohol. Alpha beta unsaturated carbonyl is reduced to allylic alcohol. Carboxylic acid is reduced to alcohol. Amide, nitrile or imine is converted to amine. And beta hydroxyketone is converted to syndiol, in which both OH are same side. And acid chloride, esters, lactones and epoxides does not reduce by using sodium borohydride. Now let's discuss about derivatives of lithium aluminum hydride, in which 3 hydrogens are replaced by alkoxide groups. These are the derivatives of lithium aluminum hydride, in which 3 hydrogens are replaced by methoxide, ethoxide and tertiary butoxide groups. Let's see how these reagents react with the functional groups. As we can see in the table, as the bulkiness of alkoxide groups increases, the reactivity decreases. Lithium aluminum trimethoxyhydride reacts similarly as lithium aluminum hydride because methoxy group is a less bulkier group. Aldehyde and ketone is reduced to alcohol, acid chloride is reduced to alcohol, ester is reduced to alcohol, lactone is reduced to diol, epoxide is reduced to alcohol, carboxylic acid is reduced to alcohol, amide, nitrile or imine is converted to amine. Lithium aluminum triethoxyhydride. This is somewhat bulkier as compared to trimethoxyhydride. So it reduces almost similarly, but amide, nitrile or imine is converted to aldehyde, as well as carboxylic acid is reduced to aldehyde. Lithium aluminum tritertiary butoxyhydride. It is a bulkier reagent as well as weak reducing agent. It reduces aldehyde and ketone to alcohol. Acid chloride is reduced to aldehyde. Ester is reduced to aldehyde. Lactone is reduced to diol, which is very slow. Epoxide is reduced to alcohol, and this is a slow process. Red aluminium or SmEAH reduces similarly as lithium aluminum hydride. It reduces aldehyde or ketone to alcohol. Acid chloride is reduced to alcohol. Ester is reduced to alcohol. Lactone is reduced to diol. Epoxide is reduced to alcohol. Carboxylic acid is reduced to alcohol. Amide, nitrile or imine is converted to amine. And alkyne is converted to transalkene. This is similarly as lithium aluminum hydride. Lithium borohydride is just as opposite as sodium borohydride. In sodium borohydride, carboxylic acid, amide, nitrile or imine are reduced. In lithium borohydride, these two are not reduced, rest all are reduced. Aldehyde or ketone is reduced to alcohol, acid chloride is reduced to alcohol, ester is reduced to alcohol, lactone is reduced to diol, epoxide is reduced to alcohol. Aluminium triborane. This is also similar as lithium aluminum hydride. It reduces aldehyde or ketone to alcohol. Acid chloride is reduced to alcohol. Ester is reduced to alcohol. Lactone is reduced to diol. Epoxide is reduced to alcohol. Carboxylic acid is reduced to alcohol. Amide, nitrile or imine is converted to amine. This is similarly as lithium aluminum hydride. Now let's get into the another page. Here, these two are the derivatives of sodium borohydride, in which hydrogen is replaced by cyanide and 3 acetyl oxy groups. Let's see how these two reagents react with the functional groups. We know that sodium borohydride is a weak reducing agent, and these two are somewhat better reducing agents when compared to sodium borohydride because these are attached to electron withdrawing groups. These two reduces aldehyde or ketone to alcohol. Sodium cyanoborohydride reduces at pH 3 to 4. Epoxide is reduced to less substituted alcohol, in which hydride attacks at more substituted site. This is a less substituted alcohol. Amide, nitrile or imine is converted to amine. Beta hydroxyketone is converted to anti-1,3-diol. DIBAL H. This is another important hydride transfer reducing agent. This reduces aldehyde or ketone to alcohol. Alpha beta unsaturated carbonyl is reduced to allylic alcohol. Ester is reduced to aldehyde at minus 70 degrees Celsius. This is very important. Lactone is reduced to lactol. This is lactone. This on reaction with DIBAL H is reduced to lactol. Epoxide is reduced to less substituted alcohol. Carboxylic acid is reduced to alcohol if 3 moles of DIBAL is used. If 1 mole of DIBAL is used, then it is reduced to aldehyde. Amide, nitrile or imine. If 2 moles of DIBAL is used, then it is reduced to amine. If 1 mole of DIBAL is used, then these are reduced to aldehydes. Alkyne is reduced to cis-alkane. This is also important application. Beta hydroxyketone is reduced to syn-1,3-diols. Borane reduces aldehyde or ketone to alcohol. Epoxide is reduced to less substituted alcohol. Carboxylic acid is reduced to alcohol. This is the best way to reduce carboxylic acids. Amides, nitrile or imine is converted to amine, and also lactam is reduced to amine. What is lactam? Cyclic amide is called as a lactam. This is a cyclic amide. This on reduction with borane is reduced to amine, and beta hydroxyketone is reduced to syn-1,3-diols. Let's see some other reducing agents. Baker's yeast. Baker's yeast reduces ketone to alcohol. Esters are not reduced by using Baker's yeast. And triethylsilyl hydride. It reduces acid chlorides and esters to aldehyde. Alpha beta unsaturated ketone is reduced to saturated ketone, and also amide is reduces to amine by using triethylsilyl hydride. Zinc borohydride. It reduces ketone to alcohol, and this is also used in NO bond cleavage. This process is called as hydrogenolysis, which I will discuss further. These are hydride transfer reagents. Now let's discuss about catalytic reduction. The name itself shows a catalyst. What is a catalyst? We know that catalyst is a substance which is added to a reaction which does not participate but enhances the rate of the reaction. In catalytic reduction of organic functional groups, we are using a metal along with hydrogen. Okay. The most commonly used metals are platinum, palladium, ranitidine, rhodium and ruthenium. Let's discuss about each metal and their functions. In catalytic reduction, addition of hydrogens takes place. Platinum in the presence of hydrogen reduces double bonds and triple bonds completely. But no other functional groups react. For example, aldehyde, ketone, esters do not reduce by using platinum in the presence of hydrogen. Palladium in the presence of hydrogen reacts similarly as platinum. It also reduces double bond as well as triple bonds. Along with this, it can reduce nitro compounds to amines and also is used for CO and C1 bond cleavage. This is called as hydrogenolysis. Hydrogenolysis is nothing but carbon-carbon or carbon heteroatom bond cleavage. Ranitidine is used for the reduction of aromatic rings. For example, let us take benzyl alcohol. So, on reduction with ranitidine, benzene ring is completely reduced to cyclohexane. And also, ranitidine is used for the reduction of thiol. If OH is present, it is called as alcohol. If oxygen is replaced by sulfur, it is called as a thiol. And this is completely reduced to hydrocarbon. And ranitidine is also used for the reduction of aliphatic aldehyde or ketone to alcohol. Rhodium reduces aromatic rings and also cyanide is reduced to amine. And heteroaromatic rings are not reduced by using rhodium. Ruthenium is used for the reduction of aliphatic carbonyl compounds to alcohols. So this is the catalytic reduction of organic functional groups. Now let's discuss about reduction of organic functional groups by using dissolving metals. Reduction in dissolving metals. For example, let us take sodium in the presence of liquid ammonia. Here we are having a metal which is dissolved in a solvent which is called as liquid ammonia. This is called as dissolving metal. This is used for the reduction of organic functional groups because these reagents donates electrons to the functional group. As we know, reduction is gain of hydrogens, loss of oxygens, and gain of electrons is called as reduction. In this way, sodium in the presence of liquid ammonia donates electrons to the functional groups and helps them to reduce. Let's see reduction of carbonyl compounds. Carbonyl compounds are nothing but aldehyde or ketone. Aldehyde on reaction with lithium or sodium in the presence of protic solvent like alcohol, it is converted to primary alcohol. Ketone on reaction with lithium in the presence of protic solvent like alcohol, it is converted to secondary alcohol. In the case of cyclic ketones, stereochemistry is very important. Let us take cyclohexanone. This is a cyclohexanone, chair conformation of cyclohexanone. This on reaction with sodium in the presence of alcohol, it produces equatorial alcohol as a major product. Because lone pair electrons on axial carbon is more favorable when compared to that of the equatorial. So now let's discuss about reduction of esters. Let us take an example. This is a diester. This on reaction with sodium in the presence of liquid ammonia, which is a non-proton donor. A solvent which can donate H plus is called as a proton donor. Here liquid ammonia is a non-proton donor. So diester on reaction with sodium in the presence of liquid ammonia produces acetylene. Compounds which are having C double bond O and OH are adjacent to each other, we represent as OIN. If pH is attached to it, then it is called as benzoin, as we popularly known in benzoin condensation. Similarly, C double bond O and OH are adjacent to each other, so this is called as acetylene, and this reaction is called as acetylene condensation. Similarly, if this diester is reacted with sodium in the presence of protic solvent like alcohol, it produces alcohol. This reaction is called as Boval-Blanc reduction. So ester on reaction with sodium in the presence of non-proton donor, it produces acetylene. Ester in the presence of protic solvent produces alcohol, which is called as Boval-Blanc reduction. Not only a diester, we can also take a monoester. Let us take CH2, CH3CH2COOET. This is a monoester. This on reaction with sodium in the presence of liquid ammonia. Similarly, it produces acetylene. Two ester molecules condense each other and form acetylene. But in the presence of protic solvent, ester is simply reduced to alcohol. Reduction of alpha beta unsaturated carbonyls. Let us take an example. This is an alpha beta unsaturated carbonyl compound. This on reaction with sodium or lithium in the presence of liquid ammonia produces saturated carbonyl, which means double bond is reduced. But in the case of protic solvent like alcohol, both double bond and carbonyl groups are reduced. producing alcohol. So alpha beta unsaturated carbonyl compounds on reaction with metal in the presence of non-protic solvent, double bond is only reduced. In the presence of protic solvent and metal, both double bond and carbonyl groups are reduced, producing alcohols. So now let's discuss about Birch reduction. This is a very important application of dissolving metals. These are applied to aromatic rings. Okay. For example, benzene on reaction with sodium in the presence of liquid ammonia produces 1,4-dihydro compound. Okay, hydrogen is attached at 1 and 4th positions. So aromatic rings on reaction with sodium or lithium in the presence of liquid ammonia produces 1,4-dihydro compounds. If there is a substituted benzene, for example, let us take electron releasing group attached to a benzene ring as well as electron withdrawing group attached to a benzene ring. Here OMe is an electron releasing group and NO2 is electron withdrawing group. So electron releasing group on reaction with sodium in the presence of liquid ammonia produces 1,4-dihydro compound, but double bond will be adjacent to the electron releasing group. If electron withdrawing group attached to benzene is reacted with sodium in the presence of liquid ammonia produces 1,4-dihydro compounds, but double bond will be away from the electron withdrawing group. This is a very important regioselectivity of Birch reduction. In the case of heterocyclic aromatic compounds, let us take indole as an example. This ring is electron rich because nitrogen having lone pair of electrons and these pi electrons will delocalize continuously. So this is an electron rich ring and this benzene ring is electron deficient. So indole on reaction with lithium in the presence of liquid ammonia, electron deficient ring undergo reduction. Therefore, benzene ring undergo reduction producing 1,4-dihydro compound. Let's see the reactivity with alkyne. Alkyne on reaction with sodium in the presence of liquid ammonia, it always produces transalkene. This is a very important application of Birch reduction. Wolff-Kishner reduction. We know that aldehydes or ketones on reaction with hydrogen produces hydrogens. This is a hydrogen. This is a hydrogen. H2O is lost here. Okay, hydrogen on reaction with base forms alkane. So aldehyde or ketone on reaction with hydrogen in the presence of base, completely C double bond O is removed and it is replaced by hydrogen. This is called as Wolff-Kishner reduction. In the case of alpha beta unsaturated aldehyde on reaction with hydrogen in the presence of base undergo rearrangement reaction and form alkene. Okay, this bond will be shifted like this, and this is converted to CH2. Similarly, alpha beta epoxy carbonyl on reaction with hydrogen, the presence of base, it produces unsaturated alcohol. This is called as Wolff-Kishner reduction. Now let's discuss about diamide. Hydrogen on reaction with oxygen in the presence of hydrogen peroxide forms diamide. This is a diamide. Diamide reduces only isolated double bonds and no functional groups are affected. Let us take an example. This is an aldehyde and this is alpha beta unsaturated double bond. This is an isolated double bond because it is not involved in any conjugation. This on reaction with diamide produces this product, reducing the isolated double bond. Crabtree reducing agent. This is a Crabtree reducing agent. Here COD is called cyclooctadiene. So Crabtree generally reduces alkenes to alkane. Either it is mono, di, tri or tetra substituted alkene, it is reduced to alkane. And also it reduces arylic alcohols to saturated alcohols. Double bond will be reduced and hydrogens will be attached from the OH side. Here OH is towards the observer, so attached hydrogens will also be towards the observer. OH, hydrogens and hydrogens. In this way, allylic or homoallylic alcohols reduces double bond from the polar group side, which is an OH side. This is about the Crabtree reducing catalyst. So this is an end of the video, guys. I tried to cover most of the reducing agents. If I forgot to mention any of the reducing agent, please mention me in the comment section. So that's all for today. Please like, share, subscribe to my channel, and thank you so much for watching.